Hello student, in today's session we will discuss about the architecture of 8085 microprocessor. Last class we have discussed about the what is microprocessor, what is microcomputer, what is microcontroller and general architecture of computer system and elements of ALU. In this session we will try to understand each block in details. So as you seen in figure, it consists of various blocks like register bit, instruction register, instruction decoder, timing and control unit, accumulator and so on. Before going to mechanism of this architecture, we will try to understand the function of each block. So first let us understand the serial input output control. These are control signal used for controlling 8085 microprocessor. These are subdivided into two types, SID and SOD. In SID, serial input data, microprocessor accept the data serially. In SOD, serial output data, microprocessor display the output serially. In 8085 microprocessor, there is a three types of buses, that is address bus, data bus and control bus. In address bus, the remaining higher order address line form the address buffer ranging from A15 to A8. This is having the unidirectional means address buffer or address bus is 16-bit, means it is identifies at A8 to A0 to A15, that is 16-bit. In higher order address bus, it is identified as A15 to A8. Or in lower order address bus, it is identifies as AD0 to AD7. Last class we have discussed about the address bus. Address bus is used to carry the address of the memory location or input output devices that the CPU wants to access, or it is by unidirectional. Address bus is a unidirectional, that means data flows in one direction from processor to peripheral devices. Address and data buffer. The address bus will be having 16 address line, that is A15 to A0, in which A0 to A7 are called as lower addressing line, and these are multiplexed with data line, that is D0 to D7, to form multiplexed address or data buffer. This address or data buffer is the bidirectional bus. That means data flow from microprocessor to memory or input output device or vice versa. Here lower address bus is combined with the data bus, that is D0 to D7, and this technique is called as multi, that is AD0 to AD7. ALU, arithmetic and logic unit. The ALU performs the arithmetic and logical operation. The operation performed by ALU of 8085 are addition, subtraction, increment, decrement, logical and or exclusive or compare, complement and left, right, shift. That is, the function of ALU is to perform the arithmetic and logic operation according to the instruction given by the user. Arithmetic operation includes addition, subtraction, multiplication, division, and logical operation includes and or exclusive or etc. Accumulator and temporary register. The accumulator and temporary register are used to hold the data during an arithmetic or logic operation. After the operation, it is store the result in accumulator, and the flag are set or reset according to the result of the operation. That means accumulator hold the data during the execution of the program, which takes place in the ALU, like addition, subtraction, multiplication, division, etc. Timing and control unit. The timing and control unit synchronizes all the microprocessor operations with the clock and generate the clock signal necessary for communication between the microprocessor and peripherals. Basically, timing and control unit act as a brain of control all the operation of the CPU or microprocessor. It also control input output and all other devices connected to the CPU, or it provide timing and control signal to control the flow of data between the microprocessor input output devices. Instruction register or decoder. When an instruction is fetched from memory, it is placed in instruction register, then it is decoded and encoded into various machine cycles. Here I will explain through diagram. This is microprocessor and this is memory. In 8085 microprocessor, memory is externally connected. Here is the program counter, instruction register and instruction decoder. This is the address bus, this is the data bus, and this one is control bus. In memory, there is a set of program or instruction. Suppose this one is the first instruction and its address is 2000. Second one is 2001. Third one is 2002. And fourth one is 2003. And this one is the fourth instruction. Suppose microprocessor wants the first instruction to access. Suppose this is the first instruction and address is 2000, and this address is stored in the PC, that is program counter 2000 address. Now microprocessor wants to access first instruction, means this instruction address is stored in the memory location and microprocessor gives this address 2000 through address bus to access this first instruction through the address bus. Microprocessor taking data from the memory is read operation RD bar, and to the memory is write operation, which is denoted by WR bar. Now microprocessor wants to access the first instruction, which address is 2000, which is stored in the program counter. Now microprocessor inform to the memory that she wants to access the first data, means microprocessor to the memory data is accessed to the microprocessor, means read operation which is given by the control bus. Now this information is received memory through the control bus. Now this instruction is given to the microprocessor through the data bus which is stored in the instruction register. Instruction is stored in the instruction register. After receiving the instruction register, instruction is in the form of binary pattern. Either it is 0 0 0, 1 1 1 0 0 0. Now this pattern is understood by the instruction decoder. This technique is called decoding. Instruction is accessed by the microprocessor through the data bus which is stored in the instruction register. This process is called fetching. This process is called fetching, and this pattern is understood by the instruction decoder which is called decoding. Stack pointer. It is also a 16-bit register which is used as a memory pointer. It maintains the address of the last byte that is entered into the stack. Suppose this one is the memory and there is a number of instruction. 2008. This is instructions 11, 12, 80. This address is 2009 200A 200B. Stack pointer is the address of the last stack top, means this one is the last stack and which is points through its address 2000B. This is the stack pointer. Program counter. The program counter keeps track of program execution. It is a special purpose register. A program counter stores the address of the next instruction to be executed. Program counter always holds the address of the next instruction. Flag register. There are 5 flags in 8085 microprocessor which are sign flag, zero flag, auxiliary carry flag, parity flag and carry flag. The bit position reserved for this flag in the flag register are shown in figure. Means flag register is a 8-bit register. It is used to provide information about the result from the arithmetic or logical operation. There is a various type of flag register. First one is the sign flag. The sign flag is set if bit D7 of the accumulator is set after an arithmetic or logic operation. Means sign flag will be set to 1 if the bit D7 of the result is 1, otherwise it will reset. Zero flag set if the result of ALU operation is 0, otherwise it is reset. The flag is affected by the operation on the accumulator as well as other register. If the result of an operation will 0, then the 0 flag will set to 1, otherwise it will reset. Flag. This flag is set 1 when a carry is generated from the bit D3 and passed to bit D4. This flag is used only internally or BCD operation. Means in an arithmetic operation, if a carry is generated from bit D3 and passed to bit the flag will set to 1, otherwise it will reset or 0. Parity flag. After an ALU operation, if the result has an even number of ones, the parity flag is set, that means 1, otherwise it is clear or 0. So the flag can be used to indicate even parity. Means if the result of an arithmetic operation has even number of ones, then the parity flag will set to 1. For odd number of 1, the parity flag will set to 0 or reset. Carry flag. This flag is set when a carry is generated from bit D7 after an unsigned operation. Means in an arithmetic operation, result in carry from the bit D7, then the carry flag will set to 1, otherwise it will reset. Overflow flag. This flag is set when an over occurs after the sign operation or sign flag. The sign flag will set to 1 if the bit D7 of the result is 1, otherwise it will reset. I will explain through example. I take two data, that is AB equal to, in binary form, A is 10, 1, 0, 1, 0. B is 11, 1, 0, 1, 1. B 9. B is 11, 1, 0, 1, 1, 9, 1, 0, 0, 1. 1, 1 is 0, carry 1, 1, 0, 1, 1, 1, 1, 0, 0, 0, 0, carry 1 is 1, 1, 1, 0, 1, 1, 0, 1, 1, 0, carry 1 is 1, 1, 1, 1, 1, 0. That is carry. This one is the bit D0, D1, D2, D3, D4, D5, D6, D7. From carry flag. This one is the arithmetic operation. If carry is generated from bit D7, then carry flag is set to 1. This one is the bit D7 and carry is generated from bit D7. That means carry flag is set to 1. Now auxiliary carry flag. If carry is generated from the bit D3, this one is the bit D3. 1, 1 is 0, means carry is generated and it passed to the bit D4. So auxiliary carry is set to 1. Now parity flag. In an result, if there is even number of ones, then parity flag is set to 1, otherwise it will reset. In this result, parity flag is 1 is 1, 2, 3, means odd number of ones, then parity flag is set to 0. Now 0 flag. Result, if result is 0, then 0 flag is set to 1. But in this result, 0 flag is other than 0, means 0 flag is set to 0. Result is other than 0. Now sign flag. If bit D7 of the result is 1, then sign flag is set to 1, that is negative. If bit D7 of the result is 0, then sign flag is 0, that is positive. General purpose register. 8085 consists of 6 special type of register called general purpose register. This general purpose register are used to hold data like any other register. The GPR means general purpose register in 8085 microprocessor are B, C, D, E, H, L. Each register can hold 8-bit data. B register is 8-bit data. C is 8 bits. Similarly, DEHL also 8-bit register. They can work in pairs such as BC, DEHL to store 16-bit data. Temporary register. This register acts as a temporary memory during the arithmetic and logical operation. Unlike other registers, this temporary register can only be accessed by the microprocessor and it is completely inaccessible to programmer. Temporary register is an 8-bit register. Temporary register holds the data during the execution of arithmetic and logic operation. It is used by the microprocessor. It is not accessible to the programmer. Now coming to the mechanism of 8085 microprocessor architecture. This one is the architecture of 8085 microprocessor. In 8085, memory is externally connected. Suppose there is a memory. Set of instruction is there. First, second, third. And this address is 2000, 2001, 2002. And first address is stored in the program counter. So starts from the program counter. The function of program counter is to store the address of the next instruction. In this program counter having the address 2000. Now this address is given to the memory that in 2000 location which instruction is stored wants to access the microprocessor. The instruction which location is 2000 is coming through the internal data bus, which is address buffer or data address buffer. This instruction is going to the instruction register. Instruction is stored in the instruction register. After the instruction register function, there is a fetching process is completed. Instruction decoder understand the which pattern is stored in the instruction register. Understanding this pattern is, that is 00001. Understanding this pattern is called decoding. This function is completed by the instruction decoder. After decoding, microprocessor execute this function which is given to the timing and control unit. Timing and control unit control all the operation of the CPU. Timing and control unit provides the control signal to each and every block. Suppose this instruction is add C, means Addition is performed in arithmetic and logic unit. Function of the ALU is to perform the arithmetic and logical operation. So addition is performed in the ALU register. To performing the addition, it requires two data. That is, from first data is always come from the accumulator, and second data, that is C, register C having the second data. Add C means accumulator data plus register B data added, and result is stored in accumulator. First data is coming from the accumulator and second data is stored in the register, which is come through the internal data bus, and this instruction or this data is stored in the temporary register. Temporary register is stored the data during the arithmetic and logic operation temporarily, and this data is coming to the ALU. ALU perform the arithmetic and final result is stored in the accumulator. There is a flag register which provides the status of the flag, that is sign flag, carry flag, parity flag, auxiliary carry flag, zero flag. We have discussed all about the flag. PSW. PSW is nothing about the program status word, which is the combination of accumulator and the flag register. 8-bit of flag register is combined with the 8-bit of accumulator. This form the PSW or program status word. Thank you.